You're moving forward in time 1 second every second. Congrats, you're a time traveler. It's not exactly the mind-blowing sci-fi kind, but it's the journey we all share. This idea might seem boring, but it sets the stage for exploring something truly fascinating: the possibility of real-time travel, the kind where you ride dinosaurs, meet Einstein, and reshape the past. But first, we need to understand what time really is. Spoiler: it's not just something that passes. Time is a dimension, like space, and part of the fabric of our universe called spacetime. Our universe is four-dimensional, combining three spatial dimensions: up, down, left, right, forward, backward, and one time dimension. Together, they form spacetime, which is like a cosmic grid where all events happen. What feels like time passing is actually you traveling through the time dimension. Unlike the freedom you have in space, where you can move in any direction, time only lets you go forward. You can't pause, rewind, or skip ahead, or so it seems. In reality, you have more control over how you move through time than you might think. To explain this without diving into complex equations, we'll need to simplify a bit and maybe annoy some physicists. There's a strange rule that governs everything in the universe. All objects move at the speed of light through spacetime, but this speed is shared between space and time. If you're standing still in space, you're moving through time at full speed, essentially rocketing into the future. But if you move faster through space, you'll slow down your journey through the time dimension. It's a trade-off: speed up in one dimension and you slow down in the other. Take light particles or photons as an example. They travel at the speed of light through space, so they have no motion left for time. For them, time doesn't exist. From a photon's perspective, it's emitted from the sun and instantly reaches Earth, with no time passing in between. Of course, this is a simplification. In reality, you can't perfectly stand still in space, and you can't define time from a photon's point of view. But it's useful for understanding the concept. This balance between space and time is why time dilation happens. Imagine a bus driving past you. It's moving faster through space than you are, so it moves slower through time. This means its clock ticks more slowly relative to yours. The faster you go through space, the slower time flows for you. This isn't just theoretical, it's been proven with experiments involving high-speed jets and atomic clocks. A famous thought experiment called the twin paradox illustrates this perfectly. Imagine one twin stays on Earth while the other travels into space on a high-speed rocket. Because the spacefaring twin moves faster through space, they experience time more slowly. When they return, they're younger than their sibling. This effect is real and measurable. With advanced technology, you could use this phenomenon to travel far into the future. Want to witness the universe's end? Time dilation could make it possible. There's another way to travel to the future: gravity. Massive objects like planets and stars warp spacetime, causing time to pass more slowly near them. On Earth, the effect is minuscule. Time passes 0.00007% slower than in deep space. But near a black hole, the difference becomes extreme. The closer you get to a black hole's event horizon, the slower time moves for you. From your perspective, everything feels normal, but an outside observer would see you moving in slow motion. When you return to Earth, you'll find that years, or even centuries, have passed. So traveling to the future is possible either by moving incredibly fast or by spending time near a massive object. But what about traveling to the past? That's a trickier question. Here's where faster-than-light travel comes in. According to Einstein's theory of relativity, if you could move faster than light through space, you'd move backward through time. Scientists have even theorized the existence of particles called tachyons, which would always travel faster than light and, therefore, backward through time. If tachyons exist, and that's a big if, they could theoretically allow us to interact with the past. Imagine sending messages to your younger self, meeting your ancestors, or preventing major mistakes. It sounds like science fiction, but it's rooted in real physics. Unfortunately, there's a catch. Relativity also says that nothing traveling slower than light can ever reach the speed of light. It would require infinite energy, which is impossible. So while tachyons work in theory, there's no evidence they exist. Without them, backward time travel remains out of reach. The past is locked away and touchable. This might sound disappointing, but it leaves us with the most important time of all, the present. Right now is the only time you truly have, and the future is yours to shape. With the right knowledge and skills, you can prepare for whatever lies ahead.